Hi everyone, welcome to your video lesson for Unit 1.4. Today we're going to be talking about end behavior, which is probably somewhat of a review from Algebra 2, but now we're going to incorporate our knowledge of asymptotes. So we know that as a function gets infinitely smaller, infinitely larger, that we can say that it approaches an infinity value. Okay, so we're looking at the ends. So we construct our end behavior statements beginning with as x approaches. That's what our little arrows mean. So we're always going to have as x approaches negative infinity and as x approaches positive infinity. So if we are approaching negative infinity, this is the left side of our graph. And if the x's are approaching positive, this is the right. Okay, so as x approaches negative or positive infinity, f of x, meaning the y values, are doing what? Okay, so are they approaching the positive y values or are they approaching the negative y values? Meaning, is the graph going up? Is the graph going down? Okay. However, now if we have a horizontal asymptote, we know that that is going to stop the graph from either continuing all the way up to positive infinity or all the way down to negative infinity because it cannot cross that horizontal asymptote. Okay, so having your grapher handy for today is going to be important, and your rules for finding horizontal asymptotes. Okay, if we do not have a horizontal asymptote, that's when you're going to need your grapher in order to see, well, what are the ends of the function doing? Okay, so we just want to review end behavior before we incorporate our horizontal asymptotes. Okay, so we start off as x approaches negative infinity. So here are the negative infinity side of the x-axis. Okay, as we are moving to the left of the graph, what are my y values doing? Okay, my y values are increasing, so they are approaching positive infinity. As the x values move to the right of the graph, okay, so as the function moves out to the right, the x values are getting larger, but what are the y values doing at that same time? Okay, so we're multitasking here. We're saying, well, the x values are going to the right, which means they're getting larger. The y values are doing what? These seem to decrease. So this is going towards negative infinity. Okay, so we'll try this again. So negative and positive x values. So as x approaches negative infinity on the left side of my graph, f of x approaches positive infinity. Okay, as x approaches positive infinity, f of x is again going to positive infinity because both ends of my graph are extending up. Okay, and last one in the top corner. So as x approaches negative infinity, f of x approaches negative infinity because it's going down. And as x approaches positive infinity, meaning the right side of the graph, f of x is increasing. That's going to positive infinity. Okay, so none of these ends have been stopped by a horizontal asymptote, so they can increase, okay, to either of their infinity values. Okay, now a lot of what we're going to do here can be done algebraically if we are assuming that or not if we assume, if we find that there is a horizontal asymptote. We don't need the graph to do the end behavior because we know what it's going to approach since it cannot cross that. Okay, so remember your rules for horizontal asymptotes. So you could factor this if you wanted. Okay, but it's going to show that nothing will cancel. So I see that the degree on the top and the bottom are equal. And we remember our rule for equal is the leading coefficient. So my horizontal asymptote here is y equals -1/4. So if an asymptote exists, your end behavior is going to approach that value. So from both sides, as x approaches positive infinity, the y values are going to approach -1/4. And from the left, okay, and your end behavior is as easy as that when you have an asymptote. Okay, now example number 2, I'm definitely going to want to do some factoring with that to see what's going on. Maybe something will cancel. Okay, I have a GCF on top and then difference of squares. Trinomial on the bottom. Alright, so I do have some values that cancel out. Okay, this is my simplified expression now. So I have 2 x's on the top and 1 on the bottom. So that means that this is top heavy. And top heavy has no horizontal asymptote, which means that we're going to look at the graph of this function. Okay, so if you want to take a minute and pause your video, get your function typed into your grapher and see what it looks like. Alright, so I'm going to draw us a little sketch here. The graph has a vertical asymptote at x equals -1. Alright, and then looks like that. Okay, now there are 4 ends here. Okay, you see 4 little arrows. We are not writing 4 statements of end behavior. We are only writing the statements of end behavior as x goes out to positive infinity, which is this guy, and as x goes out to negative infinity, which is this guy. Alright, so we're looking at as x goes to negative infinity, f of x, this arrow appears to be going down. It's a little squished there. Alright, so that's approaching negative infinity. And as x approaches positive infinity, what is my right side arrow doing? Looks to be increasing. So f of x is going towards positive infinity. Okay, so you do need a grapher. You may use the grapher when there is no horizontal asymptote in order to determine your end behavior. Alright, take a look at 2 more examples. Alright, so a lot of factoring, simplifying to be done here on example 3. All right, and when you need to factor, you don't have to show your grouping, okay? But just remember that if there is no grouping work and the factors are not correct, there's no partial credit for that. All right, so I can cancel these. So my simplified function here, okay, so my degrees appear to be equal on the top and the bottom. There's one x on the top and one on the bottom. So that means my horizontal asymptote does exist. It's going to be leading coefficients. So I'm looking at y equals 2. All right, so in order to do the end behavior for this, I do not need a graph. So as x approaches negative infinity, I know that my y values are going to approach the horizontal asymptote. And as x approaches positive infinity, the y values are also going to approach 2. Okay, if you wanted to use your grapher to verify your answer, that's perfectly fine as well. But you do want to show your horizontal asymptote and the work that you did to get there. All right, and last, this one should be pretty easy. This is very clearly bottom heavy, okay, which means that my horizontal asymptote is y equals 0. Okay, and that means my end behavior is going to approach that value from both sides of the graph. Okay, so again, use your grapher if you want a visual representation to verify that that is true. Okay, so that is everything you need to know for end behavior with horizontal asymptotes. Please make sure that your notes are complete and you write down any questions that you